formal type, easy to understand, where after applying the controlling or before applying the control, how exactly the comparisons are made and what treatment is given and how exactly to arrive at the results after certain treatment is introduced to the groups. So these are the three things we have studied. Before application of any control, then only analyzing the results after control and comparing them with the ones before the application of control, and both the groups where after the control is applied, how exactly the results vary. In the next type, that is the formal experimental designs. So here, first thing we'll have to understand what is this completely randomized design means. Now, one common example I would like to give, I think in the previous class we had taken example of a food eating habits in a hostel. Now, the same example if I take today, completely randomized design means the entire hostel, you are giving them certain food. And I think for the three examples, we had introduced the concept of introducing pizza as a breakfast. Then how exactly the student population behaves to the introduction of pizza. Whether they accept it as their regular breakfast or they don't accept. If some people have accepted it, then what is the population? Now, slightly taking this example forward, now completely randomized design means just instead of not having a particular day as such, once in a while you provide them with different kind of a food. So randomly, just randomly in a month or in a fortnight, introduced one food randomly. How many of them take it lovingly? How many of them reject it totally? And how many of them it's okay like to have once in a while? So this kind of a thing completely on a random population and randomly introducing something and testing it. This is a complete randomized design or popularly known as CR design. And in our daily life, this is very, very commonly used in all our life. This completely randomized design, and coming to conclusion on that. In many examples, you come across this only, randomization. Like suddenly change the period and somebody comes, okay, all will accept. So not much of impact on these designs. So now to arrive at concrete conclusions, this is slightly modified. The same randomized design, not the completely randomized, a simple randomized design is modified. It involves two principles. The first one is the principle of replication and the principle of randomization of experimental designs. Now, what these two are and how exactly they are applied in examples, we'll take up and then discuss. So, in randomized designs, what you have is usually the samples are divided into two groups, which is called as the first one, two group simple randomized design. So usually here it is divided into two groups. One group is called the experimental group. The other one is called the control group. Now what is the basic difference between these two groups? You just go to a random population. It is not that, okay, in this group, this particular set of people should be there. Nothing like that. Just take entire random, like suppose 100 students are there in a class. Randomly, you just choose that, okay, first two rows with 50 students in one group and second two rows with 50 students in another group. That's all. Now, after that, one is called experimental group. The other one is called control group. Now, what is the difference between the two groups? On the experimental group, you are giving a different treatment. On the control group, another treatment is given. Let us call these treatments as A and B. Now, why this is experimental group? Because for which you are testing, for which cause you are testing, that is experimented with treatment A on this experimental group. Another one can be without any treatment or a very minor treatment. Now, the same example, if I want to take it forward, very regularly on these two groups, pizza is regularly given on every Monday to these people. Whereas on the control group, any day it is given, not necessarily on Monday. It may be given or may not be given. Or if it is given any day, there is no specific time or day as such. So this is a control group. No strict guidelines to find out for this. But whereas on the experimental group, every Monday this is going to be. Now what will be the mental makeup of these children? How do they accept it as a breakfast? Or another example I would like to give, people are actually experimenting it. Now in this situation of pandemic, vaccine is administered. Now, what are the food items which are going to have adverse effect after taking the vaccine? This is one study which is being conducted. Why some people, their blood is getting clotted or some adverse effects people have? For this, is there any relationship with what they eat or what they have already had? Are they taking regularly some medication? Food in the sense, not exactly food. Their body is having any regular medication or anything. So this is one study. Now, if I apply this two group randomization, you have set of population again randomly selected and divided into two groups. On the experimental group, a specific food is given before administering the vaccine for say few days, 15 days or so. Only then the vaccine is administered and then their body or other reactions are tested. Whereas on the control group, randomly whatever food they are taking, let them go ahead and take. Now what is the success rate or failure rate, or what is the reaction rate on these people? So one experimental group on which you are giving specific food or specific medicine and then vaccine is being administered. On the other group, there is no specific control as such. There is no specific food given as such. But still their reactions are monitored and their numbers are exactly same. 50 here, 50 here. Because the sample size, whenever you go ahead with this, should be correct. You cannot have for 100 people you test it, on another thing experimental group only 50 are taken. No, that is not the requirement here. You have to divide the group into exactly two groups, then administer these kind of things and study how exactly they will. So this is simple randomized design. So the next one is random replications design. Slight modification in the first one is this random replications design. Because in the first one, they observed that only two groups, it is not correct to monitor and they will not give us the correct results. There may be some disturbances in these groups. So what they did is, further these two are divided into two more groups. That means experimental group with 50 is now divided into two blocks or two groups with 25 each. Similarly, the control group with 50 is further divided into 25 each into two groups. So in each one now you have two groups. So the replication means whether the treatment, which is again the same treatment is administered to these two. But when you further divide into two groups, is there any similarity between the two experimental groups or any similarity between the two control groups, or is there any variation? You are further minuting the results. Smaller groups you are creating and whether the same results are being replicated there. You are trying to find out that. So here basically to avoid certain kind of irregularities, these are done. So there is not much of a difference. So replication is further dividing into smaller units. This is what is replication design. Now the next modification is randomized block design technique. Now what is this randomized block design? We know what is random design now. Randomly select a group. There is no specific parameter or characteristic in selecting. Just one common factor is you are performing a research on certain group. There is no distinction between the age group, class, or the other food habits or nothing. Just select a population, divide it into two groups. That was your random technique. Now here, when you come to block design, further these are divided into smaller groups. Now before this, I would like to take you to this. Yeah. Two group, simple randomized technique, entire population, randomly selected. Then you have the sample set, that is of 100 samples. Now randomly assigning one into an experimental group, another one into a control group. And for these two different treatments are given. Treatments in the sense, either the example of administering pizza on Monday, or in case of the corona virus treatment, administering a specific food to these people, and to these people there is no specific food given. Common food, what they eat. There is no distinction on veg, non-veg, or in veg again specific food, or in non-veg again specific food, nothing like that. Whatever daily they are having, that food. Definitely there is going to be difference between these two characteristics. What food these are eating is definitely administered completely to with some rules, whereas there are no rules here. So this is the two group design, and the next one is a further dividing that into group 1, group 2, group 3, group 4 in this. I had taken example of dividing further into two groups, that is 25 each. Here they have taken experimental group, they have divided into 4, and the control group they have divided into 4 more. So this is your simple two group design, slightly modified to arrive at the results or to eliminate few of the irregularities that may happen. Now what these are, we'll find out. So this is basically a replication of the groups. Group 1, group 2, group 3, group 4, exactly they are going to have the experimental group only, and the same thing is going to be administered. But only check is whether these smaller groups are going to be replicated in their results or no. Similarly, for the control group also, the replication is observed. Now, after understanding the smaller groups, now what is this randomized block design? In the randomized block design, the principle of local control can be applied along with other two principles of experimental designs. Now already we know what is the control, what is the treatment. Now all the three, when they are applied, that is the applying the control and giving some treatment, that is whatever we have studied in two group or the replication group. So all these three, when they are combined, the result is randomized block design. So there is a randomness, that is any population is chosen, then it is divided into two groups, and those two are further divided into smaller units, and then the experimental or the control groups, they are given whatever treatment has to be given to them. So in the RB design, subjects are first divided into two groups known as blocks, such that within each group, the subjects are relatively homogeneous in respect to some selected variable. Now, what is this homogeneity word? This homogeneousness says that there is some commonality between the replication, whatever the blocks or whatever we are making, there are some common factors. So that lot of randomization which was there general, that is slightly removed so that you can arrive at the conclusions with the smaller groups. So this analysis we can do with two-way ANOVA. So because you are further divided into smaller units. So one-way ANOVA and two-way ANOVA. ANOVA is basically analysis of variance among the groups. So two-way ANOVA, it gives us the results. Now when we go to the next unit, or before that only, I will explain what exactly this two-way ANOVA and one-way ANOVA are. Okay. So basically when you arrive at smaller blocks, you have the design becoming slightly more and more complicated, and the observations have to be more and more specific. So in the same one, what you have is the Latin square design, or commonly known as LS design, is an experimental design where very frequently this is used in agricultural research. Now we'll see what exactly this LS design or Latin square design. The next one is the factorial design. Now this factorial design has got a lot of advantages. Let me go to, here the random block design with the help of an example. Suppose 4 different forms of a standardized test in statistics were given to each 5 students. Now there are 5 students and you are giving 4 different forms of a standardized test. So form 1, form 2, form 3, form 4. These are the 4 different forms of a standardized test. Some test is being conducted and you have been chosen 5 students for testing. Now selected one from each of the 5 blocks. See, and following are those which are, okay, you have here. So when you have 5 blocks like this, in each one the test results are like this: 82, 90, 86, 93. So among them, if you are choosing high, low or something, among these 4 levels, you can select. And again among them, what is their scores, you can select. So here again, you can select different 4 tests. So on which the student has scored good, on which the student has scored less, you will be able to analyze. From this, what will you come to know? Okay, this is one question. And why this kind of a tests are conducted usually for the crops or general agricultural fields or even on the random population for conducting the social behavior, study of social behavior or behavioral sciences, these are most commonly used. Just I am showing you this test and the result. I'm not analyzing it yet. So now next we'll go to this LS design. What we said, this is most commonly used for agricultural fields. Now here you can see there are small cells formed. Now fertility level, okay, fertility level of the field. Now seeds, the differences in seeds. Now here basically both are independent on one another, but the yield is dependent on both of them. Yield of the land is dependent on both of them, whereas these two are two independent parameters. Because these two are not directly dependent on one another at all. So now here you have seed differences, say from X1 to X5, 5 levels of seeds. Good quality, very good quality, or medium quality, or very low quality, or completely important category. So like this you have 5 levels in seeds. Similarly, the land fertility is also divided into 5 levels. So the lowest fertile, then go to medium, the middle level, or the good level, then excellent level. Something like this, you can divide it into this. Now, after this, what is going to be the crop yield? If you are planning to predict something like this, both these parameters are going to be very, very important for the design. Like this, you can level wise divide into as many levels as you want. But as you go on increasing the number of levels here, it will become more complex, first thing. Second thing, the results may not be very good because there is going to be some level where you have the overlapping regions. You can neither categorize into a lower level nor into a higher level. So optimum levels should be chosen here. Even difference in the seed quality also, optimum levels should be chosen. Only then the design will not be very complex. Plus it will give you good results. The next one is factorial design. So in factorial design, you have good number of factorial designs available. There is what is known as simple factorial design. And in the simple factorial design only, you can make it into different levels. What example I gave earlier, the LS design, different levels of seeds and the levels of fertility of the land. Similarly, in the simple factorial design also, you can take two independent ones. And by choosing different levels, you can have slightly a complex design in the simple factorial design itself. So the simplest one may be either 2 by 2 simple factorial design or a simple 3 by 4, 5 by 3 like this. Now these one is level here, another one is a parameter or a factor. So one is a factor indicates, other one indicates the level. Now what this factor and what this levels are, we'll see them. Similarly, in the complex factorial design, experiments with more than 2 factors at a time. More than 2 factors at a time, and for each factor, multiple levels. More than 2 factors, and for each factor, multiple levels. And then their impact is studied. So this is called as a complex factorial design. So the design used will be termed as 2 by 2 by 2 complex factorial design. So it is a three-dimensional one, which will contain a total of 8 cells, means 2 raised to 3 it is simply, where 2 factors, each one with 3 levels. 2 factors, each one with 3 levels. If you all remember your permutation combination sums, somewhat like that it is. The complex factorial design is somewhat like your different permutations and combinations, and which gives you the best result. See, with the 3 coins, all heads, all like that we have studied, no? 2 raised to whatever 3. Total number of 8 combinations. If you take 4 coins, your possibilities will be more. 2 raised to 4 or 16. So each one will have different combinations. Similarly, here also in the complex factorial design, it is somewhat like that. Just to make you understand and think on those lines, I gave this example. Otherwise, there is no one-to-one matching between this and the permutation combination. So factorial design basically deals with different factors and levels assigned to each factor, and their behavior and arriving at optimum solution is your simple factorial design. Now, how exactly this is achieved? So here in your book, they have illustrated with a simple example for 2 by 2 factorial design. Graphically be depicted as follows. Now, what exactly this says? So this is the experimental variable, experimental set, and you are planning to, as usual, 2 groups. So you are 2 treatments. So level 1 and level 2. For these two levels, and for the second group also 2 levels. So 2 factors, 2 levels. So in all, it is going to give you 4 possible combinations. So here it is further elaborated with some example. You can see here treatment A and treatment B. They have considered an example of a training given to 2 groups. A training, assume that okay, AI training is given to your class. Now we'll divide exactly 4 plus 4. Now 4 are going to receive 1, 4 are going. Again in these 4, what is done is we are categorizing these 4 students of group A into 2 groups with high IQ, with low IQ. Similarly, in the other also, we are classifying them into high IQ and low IQ. Or some test is being conducted and you are classified into 2 groups. And for each one, when the treatment is given, how exactly they respond. Then their results are consolidated and arrived at, okay, if you group them like this, you are going to get this kind of a result. If you group them separately with IQ wise, it is going to be this result. Now, when this at PG level or PhD level may not make much difference, but usually at the lower levels, where the other parameters, suppose at PUC level, PUC 1 and 2, the students, they have other control parameters like the distractions, mobiles or social network. All these are also, they are not directly dependent on the complexity of the subject or on the teacher, nothing to do with the study as such, but definitely they act as some control parameter. These control parameters cannot be ignored, but what happens, because they are independent variables for this particular situation, they are in some cases ignored. So to avoid that, what is done is the complex factorial designs are designed. In simple factorial designs, all these parameters are not considered. Only 2 by 2 means only two groups, they are divided into high IQ level, low IQ level, and the same contents are delivered to them in the same method, and the results in the same method. If the contents are delivered, definitely you can expect that the low IQ person may not grasp it at this rate. So naturally, you are expecting lesser results. That is what here the column mean and row means indicate. See, level 1, low. So here the mean is definitely going to, assuming that it is a low IQ group, here the means, whatever it is, treatment A, treatment B, when the contents are delivered, they are going to be low only. Similarly, when you are considering one low, one high, the mean is going to be definitely, that is only one group, say either experimental group or control group. Here what is taken? In both, whether it is experimental group or control group, low IQ people are going to be delivered the content. So their mean is going to be definitely low. Whereas here, one low IQ group, one high IQ group, same content is delivered, same treatment, that is treatment A only is given. Then the results, the column mean, the average is going to be definitely better because there is one high IQ group involved in this. The same thing applies to your control group as well, where treatment B, the general teaching is done. There also, the the high IQ group is definitely going to perform well. So here the mean is better than this, the row mean. That is because both are high IQ groups here, whether treatment A is given or treatment B is given. The end result is going to be good. It is like saying, parents usually say, like if the children are good wherever they study, whichever college, whichever school they go to, their performance will be definitely good. But in that, if proper timely guidance is given to a group with good IQ and good moral values plus good motivation level, then definitely the results will be good. This is what this row mean in the second row is indicating. Good guidance, good inputs, good IQ level, then definitely the mean is good. So this is what the indication is, the simple 2 by 2 factorial design. So this is in a different way, it is depicted here. Similarly, the same thing is applied to even behavioral sciences or agricultural studies. This is widely used. This actually, when you take up your research in the experiments, now I'm going to discuss this. Here I'm giving you the intro to it, but in the experiments, we are actually going to use some of your research papers we are going to take up, and then how exactly for that particular research paper you can apply this different factorial designs, whether it requires simple factorial design or complex, we are going to discuss, and after that the data is going to be analyzed. Okay, so I'm giving you the brief idea how exactly the design can be done. Now here 4 by 3 simple factorial design. Now what exactly this 4 by 3 means? 4 factors, 1, 2, 3, 4 factors and 3 levels. 4 factors and 3 levels. So in the earlier case, slightly here, confusion was 2 factors and 2 levels. 2 levels, 2 factors. So it was giving us 2 raised to 2. So similarly, 2 factors and 3 levels. 2 raised to 3. So this model of a simple factorial design includes 4 treatments. 1, 2, 3, 4, and each treatment has 3 levels. This actually, when you, I think the social networking media, there you can include this parameter. Actually, that day we had not discussed. So in the next discussion, when we take up that, when we are briefing, after everybody completes, I will take up this with that example. How exactly the different parameters, what he has taken, and some inputs I gave to Virupakshaya about this, where you can introduce these things. Virupakshaya, if you are there, you just think like this kind of a different level and different parameters or factors, how exactly you can apply to few of the questions you have asked there. This complex factorial design.